Hello biology and welcome to a quick video going over the soil lab assessment. A reminder that you are going to be answering these two questions, the argue and the evaluate, and if you are going for the for, you can also work on the prediction. I'm quickly just going to go over again the data sheet, which you should have made a copy of, but a reminder that we have in the unadulterated data, we have groups that are colored, we have tree species, we have soil moisture data. This means 34% soil moisture. That'd be a very wet soil. We have percent sand, silt, and clay. We have soil type. We have soil pH. And we also have data related to percolation and wet mass. In terms of the two questions, I think it's really important that you duplicate the data. And I would call one species. Oh, can't do, I'm going to call this species 2. And then if I go here, duplicate, come on, group. Okay. So I'll come back to here in a second, but let's take a look at our first question, which I believe is right here. You're thinking about arguing in one paragraph a species that is a specialist by using data from the PowerPoints and from collected evidence. You're going to be wanting to use context based on what a niche specialist is and the factors that make them a specialist. Find data in our location or sites that make them a specialist and compare and contrast that with the tree atlas data. You might additionally argue if your species is thriving or tolerating in stow. So in terms of the data that I have, if I go into Schoology and look at any given species slide, I have range maps for both Vermont and the United States, which can tell me how big is its range and how common is it in a given forest. When I then take all of those forests and plot them to different climate factors, I can see whether their range is big or small. Reminder that numbers are important. So 31 to 60 might be what I would say the ranges for the precipitation of balsam firs. That's a pretty big range given that you can double the rainfall and the species still does almost as well. On the other hand, it looks like balsam firs really do well between 36 and 44 degrees, maybe even less. That's a much narrower range. Again, we can talk about range in a second, than precipitation. We have sand and clay, and we also have soil productivity, which is a measurement of how good the soil is. A measurement of one would be stuff like 100% sand, 100% clay, and again, aridity is measuring soil moisture. I think this is really important because this will help you with both your first and second paragraphs, these predictor rankings. So when I look at the balsam fir, the two most important factors that explain where trees are is actually temperature. So this might be where you use climograph data from the last slide here. Then it gets into sand. So again, that would be stuff you could use. And I see sand again. Again, here's the climograph data in Fahrenheit for Vermont. So you might have to convert this into Celsius, but this data exists here. So you now then have a pretty good idea as to what your species is. Let's say balsam fir, and they really are a specialist based on sand. You go into here. I'm going to do Control A twice. Data sort range. Advanced range options. Data set a row. Tree species. And then I am going to, by holding down Shift if you're a Mac user, delete all of the data. Hello, balsam fir. That I don't want. Great. So now I just have balsam fir. Now notice they are in a lot of sites. So right off the bat, that is a little suspicious given that it is, pretty common. in our forest in terms of 1, 2, 3, 4, 5, 6, 7 sites, but they never tend to dominate a site. So that might mean that they could be considered a specialist if they're never really dominating one particular site. The stuff that I really care about is the sand. So I'm going to press equals. This is going to be where I do my computation. So I'm going to do average equals average. That's identifying that I want it. 62%. We'll talk about that in a minute. I'm going to do range equals min or max of this minus min of that. 56% is pretty big. So that's something to think about. Let me just double check that I did that correctly. Yep. And then standard deviation. Whoops. Which again is talking about how variable the data is. Equals standard deviation. Highlight the data. 16%. That's not terrible. It's not awful. So I have these computations which I could use in my argument, but I also want to go back here. I go to percent sand, and it does look like in that 40 to 50-ish range, the balsam firs are really thriving and doing well. So if I go into my data sheet, I could then think about all of the examples I see where I see the balsam firs doing really, really well. So this again is where if you look at your lab assessment, compare and contrast. This means that you might consider how our forests and trees fit within the data set in the atlas. This does not mean it always matches. So the second question is really asking you to compare and contrast two different sites, look at the species in those sites and talk about whether they're a generalist or specialist, and then cite data as to why one site might have many species and the other one is more specific. So when I go into my data sheet, I'm going to now go into groups, and I am going to delete data. I'm going to keep Alan Grace and Thomas here, and I am going to get rid of all of these people. I am looking for a particular... I'm going to get rid of all of these groups because I noticed that Lucy, Travis, Kara, and Romarco had a lot of hemlocks. Bingo. So then all I'm going to do, move this data up, highlight it. I'm doing that over here. When you highlight data, you'll see a hamburger helper hand. This allows you to click and drag. I'm going to do that right now, so it's all at the top. Bada bing, bada boom. I'm going to go over here. Ooh, you guys did not calculate your soil types. I'm going to do average. Highlight the data. Error in the formula. So on and so forth. And so I'm going to be looking at why is it that these sites are so different in terms of numbers of or types of species and also their data. So that involves not only having averages, but I need to have standard deviations. To do that, press equals standard deviation. Ooh, that's pretty small. Equals standard deviation. Oh, surprisingly, it is bigger. So again, this is where you're going to be doing computations and you're going to be trying to make sense of the data as best as possible, which means you're probably going to have to be looking at the PowerPoint data. The PowerPoint data is really useful for trying to contextualize when I look at this group's data, why is it that 7 out of 9 of their trees are eastern hemlocks? When I go into my soil lab, remember, you can copy and paste all of the graphs you want in here. And then it's going to be really the data tables that take time. So table 2, comparing Travis and Grace groups. When you go to make a data table, all you're going to do is insert table. I always just make up a table that I think will be good enough. And then I can always right click and delete rows or add rows. So this might be group Travis Grace, and then maybe this is average sand, standard deviation sand, range sand, soil types. I'm doing a bad job of typing. Anyways, that's how you make a data table. And I think we've gone generally over how to analyze data for both groups. Remember, Monday and Tuesday are work days, so coming in with questions that I can do to help will be really useful. These are CERs. At this point, you should really know what a CER looks like in terms of context, evidence, and reasoning. So I'm here to help, but know that you have many resources to help you as well. Thanks, and have a great Sunday.